I think you've come to this page because you really want to know the solution to this system, how it works. So let's do this. I'm going to name that top equation number 1, the bottom number 2, and I'm going to use the method of elimination by addition. And here's my approach to this. What I'm going to do is I'm going to eliminate y, and that will get me x. I'll run through that method, and then I'll do the same thing, but I'll eliminate x and get y. To eliminate the y's, I'm going to focus in on those y coefficients and get them to be opposites. Right? If they're opposites, they would add to 0, and they'll disappear. Now, I talked about opposites in chapter 0 right up front. So you may want to look at that if this doesn't make sense. But let's go from here. So I want these to be opposite. So I'm going to look at these coefficients. What does the smallest number both 2 and 3 divide into? It's 6. Now they already have opposite signs. So here's my plan. I can make these 6's, right? If I multiply this by 3 and this by 2, but I have to multiply through the entire equation. So here is the plan. It's going to be 3 times equation 1 plus, and then I'm going to add that to 2 times equation 2. So this is just a notation. It says to take 3 times equation 1 and then add to that 2 times equation 2. So 3 times equation 1. So take this 3 here and multiply it all the way through that first equation. It looks like this. 21x minus 6y equals 18. Let me just check that. I'm multiplying by 3. So I get 21, 6, and 18. Negative 6. Okay, it looks good. And now, for that second equation, I can turn that to a 6 if I multiply it by 2. So take that 2 and run it through that entire equation. It will look like this. 8x plus 6y equals, and I'm multiplying by 2, so negative 10. We'll add these together, getting 29x. And now you see, negative 6y and positive 6y, that adds to 0, so that's gone. So this is equal to, what do we get here? 8. So divide by 29, right? And we will get x equals, let's write it, equals 8 over 29. Now the next part is this. I'm going to eliminate x and get y. So to eliminate x, focus in on these coefficients of the x's. What's the smallest number they divide into? Well, they both go into 28. Now, I'm going to turn these into 28. So I'm going to multiply the top equation by 4 and the bottom equation by 7. But I have to be careful here. These have the same sign. So I want opposite signs. So just make one of these signs opposite. Pick a negative multiplier. And I will pick that for the first one. So my plan is this. Instead of just 4 times equation 1, I'm going to take negative 4 times equation 1 and then add to that, okay, and get a 28 here if I multiply by 7. So 7 times equation 2. Here's what we get. So take that negative 4, multiply it all the way through equation 1. Now I'm multiplying every one of those coefficients by negative 4, so I'll get negative 28x, positive 8y, and negative 4 times 6 is negative 24. Let me just run a quick check. So what did I do? I multiplied by negative 4, so I get negative 28, positive 8, negative 24. It looks good. Now, in the second part here, I'm going to take 7 and multiply it all the way through equation 2. So we'll get 28x times 3 times 7 is plus 21y, and 7 times negative 5 is negative 35. Add these together, the x's are gone, and we'll get 29y equals what? This looks like negative 59. And then making our division here, we're going to get y is equal to negative 59 over 29. And I'm just going to write this up here and summarize it. X is 8 over 29. Y is equal to negative 59 over 29. There we go. And if we were to graph these two lines, right, they're two lines, right? First degree, so linear equations. If we were to graph these two lines, they would intersect. See if I can draw it here. It would do maybe something like this, right? I got these two lines. They're going to intersect right at this point right here. To the right 8 from the origin. To the right, 8/29ths of a unit, and then down 59/29 units.